Determine whether the triangles are congruent by the angle-angle side triangle congruence theorem. Given angle E is congruent to angle C. Okay, now if we're going to do angle-angle side triangle congruence, we need another pair of angles. And angle F and angle B, those are both right angles. And I'm not just making an assumption here. On a coordinate grid, when you have horizontal and vertical segments, the assumption is those are right angles. So it's actually okay for me to put that in this case. If there was no grid here and no axes, I shouldn't do that. But in this case, it'll be okay. Okay, now there are two different ways to do angle-angle side from here. We could either do these segments, FD and BA, or we could do these segments, DE and AC. Now if we're going to do FD and AB, those two segments, we could just look at it and say, well, it looks like 3, so we'll just put that. Like we could just say 3 and 3. I also want to talk about segments ED and CA. What if you have to find those segments? You have to use the Pythagorean theorem or the distance formula. Now if I was going to use the Pythagorean theorem, I already have my 3 for FD, and then 4, and then 4. So to find DE, we say DE squared equals 3 squared plus 4 squared, which is equal to 9 plus 16, which is equal to 25. And that's DE squared. Take the square root of both sides and get DE equals square root of 25, which is simply 5. Okay, and the same reasoning can be applied to the other triangle. I can say that AC squared equals 3 squared plus 4 squared, which is 9 plus 16, which is 25. And that's AC squared. And I can square root both sides and get AC equals square root of 25, which is 5. So DE is congruent to AC because of the angle-angle side. And you could use either angle E, angle F, and then segments FD and AB, or you could use angle F, angle E, and segments DE and CA. Now the important point here is that when you have triangles on a coordinate grid, you end up using the Pythagorean theorem, or the distance formula as it can also be called. Now the distance formula itself runs off just pure coordinates, and that's a little more complicated to do, but sometimes it's necessary. But I prefer to go by the Pythagorean theorem whenever I can. It's really the same idea, but a little simpler to work with.